Hello, my friend, and welcome back to Sleepy Science Quest. I am so glad you have chosen to spend this quiet moment with me. Tonight, we are going to explore the boundaries of what is possible. We are stepping into a story of science, patience, and the incredible engineering required to bend the very fabric of the universe. It is a tale not of magic, but of mechanics. A journey into the construction of a bridge across time itself. We will walk alongside the engineers who attempt to turn the impossible theories of physics into a concrete reality. If you are new here, our goal is simple: to help you disconnect from the rushing world. Through slow storytelling and soft ambient narration, we create a space for you to unwind, let go of the day's tension, and perhaps drift into a deep, restorative sleep. There is no rush here, and nowhere else you need to be. So, please, find a comfortable position. Loosen your jaw, drop your shoulders, and take a deep, slow breath. Let the noise of the outside world fade away. Close your eyes, and let's begin. Alara stood behind the thick safety glass of the observation deck, looking down at the immense machinery that filled the belly of the Kronos station. It did not look like a science laboratory. It looked like a heavy industrial plant, a place of grease, steel, and brute force. This was a factory, built for a single, terrifying purpose. "It is strange," Director Kale said, standing beside her. He adjusted his suit, looking nervous. "We spent 50 years thinking time travel was a matter of delicate equations on a chalkboard. But looking at this, it looks like we are building a battleship." "We are building a tunnel, Director," Dr. Aris replied. He was the chief physicist, a man who looked like he hadn't slept in a week. He pointed a thin finger at the workshop below. Kip Thorne and the old physicists thought wormholes were outrageous. They thought maybe we would find one floating in the galaxy, left over from the Big Bang. That was wishful thinking. A spacefaring civilization cannot wait for luck. We do not find wormholes. We manufacture them. Alara checked her tablet. End of Chapter 217. All systems were green. The production line was ready. "We are approaching T-minus 10 minutes to stage 1, she announced. "The collider is primed." This was the first of 4 workshops arranged in a line. The collider, the imploder, the inflator, and the differentiator. It was a 4-stage assembly line designed to tear a hole in the universe and keep it open. "Remind me again," Kale said, watching the technicians scurrying below. "Why is the first machine so large? Why can't we just fold space?" Aris sighed, the patience of a teacher explaining a difficult concept to a child. "Imagine a sheet of paper, Director. That paper represents space. If you want to connect 2 distant points, you fold the paper over until the points touch. That is the classic explanation. But there is a problem." "The paper touches," Kale said. "So the connection is made." "No," Aris corrected. "The surfaces touch, but they are not joined. To actually make a wormhole, to make a tunnel you can walk through, you have to cut the paper and paste the edges together. You cannot make a donut shape out of a ball of clay without tearing a hole in the middle. It is a problem of topology." Alara nodded. She knew this part well. And you can't just cut space, Director. If you slice into the fabric of space-time near Earth, you expose a raw edge. That creates a singularity. It is infinite density, a point of total destruction. It's too violent. It would destroy us before we even started. And so we don't cut, Kale said. We borrow. Exactly, Aris said, his eyes gleaming. We use the quantum vacuum. We use the laws of Heisenberg's uncertainty principle. In the quantum world, nothing is fixed. Energy fluctuates. It is like a bank loan. You can borrow energy from nature as long as you pay it back quickly. The bigger the loan, the faster the payback time. Aris walked to the window, looking at the massive ring of the heavy ion accelerator below. If we look at the tiniest scale of the universe, the Planck length space is not smooth. It is a foam. It is a chaotic storm of tubes and tunnels appearing and disappearing. Wheeler called it space-time foam. These are quantum wormholes. They are ghosts. They exist for only a fraction of a second. So we are catching ghosts? Kale asked. We are harvesting them, Alara said. Those ghost wormholes are virtual. They live on borrowed time. Our job, starting now, is to pay off their debt. We have to inject enough energy into that foam to clear the loan. We turn a virtual wormhole into a real one. Stage 1, Elara announced into her headset. Power up the magnets. Below them, the hum of the collider began to vibrate through the floor. This machine was a monster, similar to the ancient accelerators used at Brookhaven, but scaled up for a godlike task. Inside that ring, Aris whispered, we are accelerating the nuclei of gold and uranium atoms. We are boosting them to colossal energies. We are using magnetic fields to trap them in a vacuum tube, spinning them in opposite directions. End quote. The lights in the station dimmed momentarily as the power draw spiked. The counter-rotating beams of heavy nuclei were reaching their maximum speed, moving just under the speed of light. Prepare for collision, Elara warned. The goal was violence. Controlled, focused violence. They needed to smash these heavy nuclei together so hard that they briefly recreated the conditions of the universe just a microsecond after the Big Bang. They needed heat. 10 trillion degrees of heat. Impact in 3, 2, 1. There was no sound, of course, as the collision happened inside the vacuum chamber, but the sensors screamed with data. On the main screen, a simulation showed what was happening in the heart of the machine. The gold nuclei smashed into each other head-on. Protons and neutrons were pulverized. They didn't just break apart. They melted. Stable, Elara reported, her voice steady despite her racing heart. We have achieved the melt. Look at it, Aris said softly. The quark-gluon plasma. Inside the chamber, the fundamental building blocks of matter quarks and gluons had been ripped free from their bonds. They were no longer solid matter. They were a bubbling, amorphous blob of superhot soup. They had melted the vacuum itself. We have created the bubble, Aris said, turning to the director, that this is just the raw material. It is hot, yes, 10 trillion degrees. But to twist space itself, to reach the Planck energy, this is still far too cold. We are 19 powers of 10 too low. So what do we do? Kale asked, staring at the readout of the burning plasma bubble. Now, Elara said, pressing a command on her console. We move it down the line. We have the clay. Now we must squeeze it. She watched as the magnetic containment fields shifted, carrying the incredibly hot, microscopic bubble of plasma out of the collider. It moved along the transfer track, heading toward the second workshop. Workshop 2 is online, Elara said. The imploder is ready to receive. The transfer tunnel hummed with a low-frequency vibration as the magnetic fields carried the quark-gluon plasma bubble into the second workshop. Through the observation window, the imploder looked very different from the collider. Where the collider was a vast, sprawling ring, the imploder was a compact, spherical fortress of reinforced steel and lead, bristling with thick cables. It looks like a bomb, Director Carl muttered, stepping closer to the glass. In a way it is, Dr. Eris replied, his eyes fixed on the monitors. But an implosive one. We have a problem, you see. That bubble we just made is hot 10 trillion degrees. To you and me, that is unimaginable. But to the universe, it is nothing. To twist space-time, we are still 19 powers of 10 too cold. Elara adjusted the controls on her console, her fingers moving rhythmically. Target bubble is centered in the chamber, she announced. Locking containment. To get the temperature up to Planck values, Aris continued, watching the screen, we must compress that bubble. We need to squeeze it by a factor of 1 billion billion. Kale's eyes widened. The energy required for that must be astronomical. Surprisingly, no, Harris said, a small smile playing on his lips. The total energy involved is about 10 billion joules. That is roughly the output of a standard power station for just a few seconds. We don't need the energy of a galaxy. We just need focus. Elara brought up the schematic of the imploder on the main screen so the director could see. It showed the plasma bubble floating in the center, surrounded by a complex array of capacitors and tungsten wires. The challenge is not generating the energy, Director. The challenge is concentrating all that force onto an object smaller than an atom. We are using a technique called the Z-pinch. Z-pinch? Kale asked. It is old technology, refined, Elara explained without looking up. Scientists used it back in the 1950s for nuclear fusion. You pass a massive electric current through a gas. The current creates a magnetic field. That magnetic field wraps around the gas and violently pinches it, crushing it inward. The Sandia National Laboratories used to do this with tungsten wires, Aris added. They could hit millions of degrees. But we need more punch. We have arranged the magnetic emitters in a perfect sphere around the target. Imagine a collection of thermonuclear bombs, all exploding inward at the exact same instant, directing all their force at a single point. The lights in the control room shifted to red, signaling the charging cycle. A deep thrumming sound filled the air, the sound of massive capacitors storing electricity. Energy levels at 90%, Elara called out. Warning, magnetic field instability is possible. Aris nodded gravely. This is the dangerous part. Quantum field theory tells us that if a magnetic field gets too strong, it might destroy itself. It could start creating subatomic particles out of thin air, dissipating the energy before it crushes the bubble. We are walking a fine line. And if it fails? Kale asked. Then the plasma disperses, Aris said, and we have just wasted 10 billion joules. Capacitors fully charged, Elara said. Her voice was calm, contrasting with the tension in the room. 50 trillion watts ready to discharge, initiating the pinch in 5 seconds. The workshop below was silent. The heavy sphere of the imploder sat motionless, hiding the violence about to be unleashed inside its core. Free. 2. 1. Implode. Elara pressed the trigger. There was a sharp crack that penetrated even the soundproof glass, followed by a sudden heavy thud that shook the floor plates. On the monitors, the graph lines spiked vertically. For a fraction of a second, the energy of a power station crashed down onto the microscopic bubble of plasma. Inside the chamber, the magnetic field clamped down. It was a violent, crushing hug. The plasma, already a soup of quarks and gluons, was forced into a space so small it defied logic. The density skyrocketed. Density passing nuclear levels, Elara reported, reading the streaming data. Passing 10 trillion kilograms per cubic meter. Climbing. Come on, Aris whispered, gripping the railing. Squeeze it. The numbers on the screen turned into a blur. They were reaching a density 80 powers of 10, greater than nuclear matter. They were pushing the bubble down to the Planck, length a billion trillion trillionth of a centimeter. This was the scale where the smooth geometry of space broke down into foam. Target density achieved, Elara shouted. Field collapsing. The magnetic pinch released. The violence ended as quickly as it had begun. Status? Kale asked, his voice hoarse. Aris leaned over Elara's shoulder, peering at the sensor output from the center of the chamber. There, he pointed, in the center of the containment field, floating in the vacuum, was something that barely registered on the sensors. It wasn't a black hole, not exactly. It was a knot in the fabric of the universe. We did it. Aris breathed. We matched the energy fluctuations of the Planck time. We didn't just crush the matter, we crushed the space it occupied. Is it a wormhole? Kale asked. It is the seed of one, Elara said. She carefully manipulated the containment fields to stabilize the tiny object. It is a traversable connection, but it is microscopic. Light can barely travel through it. Aris stood up, looking triumphant but exhausted. We have successfully pierced the veil. We have a real physical wormhole. It is no longer virtual. We have paid the energy loan. But it is useless, Kale said, looking at the empty seeming chamber. It is smaller than an atom. We cannot travel through that. Of course not, Aris said. It is a baby. Now we must feed it. We must make it grow. Elara engaged the transport fields again. The tiny, invisible knot of twisted space was carefully moved from the crushing grip of the imploder toward the third workshop. This was the brute force stage, Elara said. Now comes the delicate work. We need to inflate it without breaking it. Workshop 3, Aris announced, gesturing down the line. The inflator. This is where we break the laws of gravity. The third workshop was a stark contrast to the heavy industrial feel of the imploder. It was silent, sterile, and filled with a complex lattice of glass and crystal. This was the inflator. Careful, Elara whispered, her hands hovering over the delicate controls. The seed is in position. On the central display, the microscopic wormhole was suspended in a vacuum chamber. It was invisible to the naked eye, a mere pinprick in reality, but the sensors tracked its immense gravitational pull. Now comes the impossible part, Director Kale said, looking at the array of equipment. You said we need to make it bigger, but gravity pulls things together. It crushes. How do you make a hole in space expand? We use the opposite of gravity, Dr. Aris said calmly. We need anti-gravity, Kale scoffed. Anti-gravity. That is science fiction. It is physics, Aris corrected. To keep the throat of that wormhole open and to push the walls outward, we need exotic matter. We need negative energy. Aris walked over to a whiteboard that had been set up near the console. He drew two parallel lines close together. In 1948, a Dutch physicist named Hendrik Casimir discovered a way to create negative energy. It is simple. Imagine two metal plates placed very close together, face to face. Okay, Kale said. Now, imagine the space between them is a perfect vacuum. You take out all the air, all the particles. You might think it is empty. But quantum physics tells us that empty space is never truly empty. It is a beehive of activity, virtual photons, ghost particles, are constantly popping in and out of existence. Aris tapped the board. Outside the plates, these ghost particles can move freely. But between the plates, the space is too tight. Some of the waves don't fit. They are excluded. So, there is less energy inside the plates than outside. If the outside is zero, the inside must be negative. And you can harvest this? Kale asked. We can, Elara interrupted. But we don't use metal plates. That is too slow. We use light. We use lasers. She pointed to the heart of the machine. It was a bank of high-powered lasers aiming at a central point. But the light didn't go straight to the wormhole. It passed through a series of crystals and rapidly spinning mirrors. We are using lithium niobate crystals, Elara explained. When we fire the laser through these crystals, it changes the pattern of the photons. It rearranges them. We call it squeezing the light. The beam that comes out has pulses of negative energy mixed with pulses of positive energy. The problem, Aris added, is that the negative pulses are very short. They only last for a tiny fraction of a second. We need to separate them. We want only the negative energy to hit the wormhole. That is what the mirrors are for, Elara said. She engaged the drive system. Inside the glass enclosure, a set of ultra-fast rotating mirrors began to spin. They spun so fast they became a blur, then invisible. The mirrors rotate to catch the beam at precise angles, Elara said, her eyes scanning the synchronization data. They reflect the positive energy pulses away into a dump, but the negative energy pulses, those are directed straight into the throat of the wormhole. Initiating injection, she announced. A hum filled the room, different from the violent noise of the imploder. This was a high-pitched whine, like a jet engine spinning up. The lasers fired. The beams hit the spinning mirrors, and to the human eye, it looked like a solid beam of purple light striking the invisible spot in the center of the chamber. "Feeding the wormhole," Aris whispered. "Drink up." They watched the monitors. For a long time, nothing seemed to happen. "The theoretical calculations are worrying," Cale admitted, reading a report on his screen. "It says here that to expand a wormhole to 1 meter in diameter, we would need negative energy equivalent to the mass of the planet Jupiter. Your lasers are powerful, Doctor, but they are not Jupiter. It would take longer than the age of the universe to build enough energy this way." "You are right," Aris said, smiling mischievously. "If we had to do all the work ourselves, we would be here forever. But we are banking on a free lunch." "A what?" "Gravity itself produces negative energy," Aris said. Stephen Hawking predicted that black holes glow with radiation. That energy has to come from somewhere. It comes from the negative energy flowing into the hole. The stronger the gravity, the more negative energy is sucked in. Aris pointed to the tiny seed on the screen. That wormhole has intense gravity. We are using the lasers just to start the process. We are kick-starting the engine. Once the wormhole starts to expand, its own gravity should vacuum up the quantum foam around it. It will generate its own negative energy. "Self-inflation," Elara said. "Look at the diameter readings." On the screen, the flat line began to curve upward. The microscopic knot was growing. It wasn't just expanding, it was exploding outward. The lasers were the spark, but the fuel was the vacuum of space itself. "It's working," Elara said, her voice rising in excitement. "Diameter is 10 nanometers, 1 micrometer, 1 microscopic. 1 millimeter. The object in the chamber was becoming visible. A shimmering distortion appeared in the air, like heat rising off hot pavement. It grew larger, a sphere of warped light. 1 centimeter, Elara called out. 10 centimeters, 1 meter. The hum of the lasers remained constant, but the sphere was now growing on its own, feeding on the fabric of reality. It expanded until it filled the center of the containment field, a shimmering ball of distortion about 10 meters wide. "Stabilizing," Elara said, pulling back on the laser power. The throat is open. Negative energy density is holding steady. It is no longer collapsing. Cale stared at it. It was beautiful and terrifying. A hole in the world. "So," Cale said, "we have a tunnel, but where does it go?" "Right now," Aris said. "Right now, nowhere. Or rather, it goes to here, just a few meters away. It is a short tunnel through space, but it is not yet a time machine. We have the vehicle, Elara said, unbuckling her safety restraints. Now we have to modify the engine. Stage 4, Aris said, turning toward the final door. The differentiator. We have a hole in space. Now we must make a hole in time. The massive blast doors to the final workshop slid open, revealing a space that dwarfed the previous 3. The differentiator was not just a room. It was a cavernous hangar containing a track that looped around the entire facility. "We have the wormhole," Dr. Aris said, walking alongside the hovering containment platform that carried their creation. The shimmering 10-meter sphere of distorted air followed them, locked in magnetic grips. But currently, it is just a door to nowhere. If you step in one side, you come out the other side instantly. It is a bridge across space. We need to turn it into a bridge across time. Director Kale looked at the shimmering sphere. "I still do not understand how we make the switch." How does a hole in space become a time machine? "We use the twins' paradox," Elara said, taking her seat at the final control station. She brought up a simulation on the main screen. It showed 2 identical clocks. "Imagine 2 twins," Aris explained. "One stays on Earth, the other gets in a rocket and flies away at near the speed of light. When the traveler returns, he will find that he is younger than his brother. He has aged less. Time for him moved slower because he was moving fast. This is Einstein's relativity. It is a proven fact." "I know the theory," Kale said. "But we are not sending people into space yet." "No," Aris pointed out. "We are sending the wormhole." On the containment platform, the magnetic fields shifted. The large sphere began to stretch. It elongated, looking like a drop of water about to pinch off. With a sound like tearing silk, the single sphere separated into 2 identical spheres. They floated a few meters apart. "We now have mouth A and mouth B," Elara reported. "They are connected by a short tunnel through hyperspace. If you whisper into mouth A, your voice comes out of mouth B instantly. They are synchronized in time." "Not for long," Aris said. "To create a time machine, we must desynchronize them. We must make time pass differently for one mouth compared to the other." Elara's fingers flew across her keyboard. "Step 1. Electrification. We cannot grab a hole in space with a mechanical arm." Confused the 2 sides. We need to give it a handle. Inside the chamber, an electron gun fired a stream of particles into mouth B. The sphere glowed with a faint blue static charge. "Mouth B is now electrically charged," Elara said. "We can now manipulate it with powerful magnets." "Load it into the accelerator," Aris commanded. Heavy magnetic clamps engaged. Mouth A was locked into a heavy concrete pedestal in the center of the room. It was the stay-at-home twin. Mouth B, however, was pulled away. It drifted toward the entrance of the massive circular track that ran around the room. This is the differentiator, Aris said, gesturing to the track. It is a particle accelerator, but instead of spinning atoms, we are going to spin the wormhole mouth itself. We are going to accelerate mouth B to 99.9% of the speed of light.
And mouth A stays here?
Kale asked. Exactly. Mouth A sits still. Its clock ticks at a normal rate. But mouth B will be whirled around at a frenetic pace. For mouth B, time will slow down. It will age more slowly than its partner. Initiating acceleration sequence, Elara announced. The hum of the facility deepened to a roar. Mouth B shot into the tunnel. Aris watched the telemetry. We usually let this process run for years. If we kept mouth B spinning for 10 years at light speed and then brought it back, there would be a 10-year difference between the two mouths. Mouth B would be 10 years in the past relative to mouth A. We do not have 10 years, Kale said nervously. For this demonstration, Aris assured him, we only need a few minutes. We just want to prove the concept. We will create a time difference of a few seconds. As mouth B whipped around the track, becoming a blur of motion, Aris turned to the director. There is another way to do this, you know. If we didn't have this factory, we could use gravity. Gravity slows time just like speed does. Like a black hole or a neutron star, Aris said. Imagine we towed mouth B to a neutron star a few light years away and parked it near the surface. The gravity there is immense. Time would crawl. We would leave mouth A here on Earth. When we brought mouth B back, it would be younger than mouth A. The effect is the same. But we use the accelerator, Kale said, watching the lights trace the path of the spinning wormhole. It is more controlled. Precisely, Aris said. And safer. We don't have to worry about the tidal forces of a star tearing our machine apart. A warning siren chirped on Elara's console. Velocity is maximum. Time dilation is occurring. The temporal gap is widening. We are currently at a differential of -5 minutes, -10 minutes. That is enough, Aris said. We don't want to get lost in history just yet. Bring it to rest. Decelerating, Elara called out. The roar of the magnets died down. The blur in the track slowed. A few moments later, the charged mouth B glided back into the central chamber. It was locked into place right next to mouth A. The two spheres hovered side by side, looking identical. Both were shimmering distortions of air, 10 meters wide. But Aris knew they were now fundamentally different. The machine is ready, Aris said quietly. Mouth B is now permanently younger than mouth A. If you look closely, you can see the difference. Kale stepped closer, peering into the swirling depths of mouth A. Look through mouth A, Aris instructed. You are looking through the tunnel to mouth B. But because of the time difference, you are seeing mouth B as it was in the past. And if I step through? Kale asked, his voice trembling slightly. If you step from A to B, Aris said, you will emerge in the past. You will jump back by the amount of time we generated in the accelerator. And if you jump from B to A, you go into the future. A closed loop, Elara said, joining them. We have tied a knot in time. But remember, Aris warned, raising a finger. This is not like the movies. In H.G. Wells's story, the traveler sits in a chair and watches time rewind like a movie tape. He stays in one spot while the world changes. Our machine is different. How? Wells' machine didn't move in space, Aris said. But that is dangerous. The Earth moves. The sun moves. If you travel back in time without moving in space, you might wake up in the empty vacuum of space because the Earth hasn't arrived there yet. Our machine creates a tunnel. You don't just travel through time, you travel through space to get to the past. He gestured to the two mouths. We have built the road, Director. The collider melted the vacuum. The imploder crushed space. The inflator opened the throat. And the differentiator twisted time. Aris looked at the two shimmering portals. The only thing left to do, he said, is to test it. The silence in the massive hangar was heavier than the machinery itself. Two 10-meter spheres of distorted air hovered above the concrete floor, held in place by invisible magnetic hands. They did not look like solid objects. They looked like bubbles of water floating in zero gravity, reflecting the lights of the workshop in a swirling, dizzying pattern. We have built it, Director Cale said, his voice echoing slightly in the vast space. But is it safe? It is one thing to send a subatomic particle through a tube. It is another thing to send a person. Dr. Aris walked around the perimeter of the containment zone, checking the final readings on his tablet. That is the primary concern, Director. The gravity at the throat of a wormhole is intense. In nature, a wormhole would crush you instantly. Physicists call it spaghettification. Cale grimaced. I assume that means exactly what it sounds like. It does, Ilara interjected from the control deck. Gravity pulls on your feet much harder than your head. You would be stretched into a long, thin noodle before you even reached the other side. It is not a survivable way to travel. But we have solved this, Aris said, gesturing to the shimmering spheres. Remember the inflator? We injected the throat with negative energy. That exotic matter does more than just hold the door open. It creates an anti-gravity effect. It pushes outward against the crushing force. If our calculations are correct, the ride should be gentle. A human being should be able to squeeze through and come out smiling. Quote, should be, Cale repeated. I am not volunteering to be the first one to test that theory. We have a volunteer, Ilara said. She typed a command, and a small robotic rover rolled out from a side bay. It was a 6-wheeled drone equipped with cameras, sensors, and a high-density battery. Meet Kronos 1. The rover rolled up to the edge of the containment field, its camera lens focused on Mouth A. The plan is simple, Aris explained. We have established a time differential of exactly 5 minutes. Mouth B, the one on the right, is 5 minutes in the past relative to Mouth A, the one on the left. Cale looked at the two spheres. They looked identical. So, if I put my hand in Mouth A, it would come out of Mouth B 5 minutes ago, Aris finished. This hurts my head, Cale admitted. It is about to get worse, Aris said with a grim smile. Ilara, prepare the drone for injection into mouth A. Start the clock. Ilara's fingers moved across the controls. Kronos 1 is moving to injection position. Telemetry is green. Exotic matter density in the throat is stable. The tunnel is safe. The drone rolled forward. It approached the shimmering surface of mouth A. As it got closer, the surface of the sphere seemed to boil. It wasn't a smooth mirror. It was fuzzy. Quantum fuzziness, Aris noted, watching the screen. The topology of space is constantly fluctuating at the edges, but the center is clear. Sending the drone in 3, 2, 1. The rover surged forward. It didn't crash into the sphere. It melted into it. One moment the drone was on the concrete floor, and the next it was swallowed by the distortion. It vanished from the hangar. Drone has entered mouth A, Ilara confirmed. Signal lost? No, wait. Signal reacquired. It is on the other side. Where is it? Kale asked, looking frantically at mouth B. It didn't come out. Aris looked at his watch. It is currently 14:05. Ours, it is currently 14:05. We just sent the drone into the machine. Because mouth B connects to 5 minutes in the past, the drone should have emerged from mouth B at 14 o'clock. But it is 14:05 now, Kale said. We missed it. Exactly, Aris said. If the machine works, the event has already happened. Ilara, rewind the security footage of mouth B. Go back 5 minutes. Kale rushed to the main monitor. Ilara scrubbed the video timeline backward. The screen showed the hangar as it was 5 minutes ago. The technicians were still making final preparations. The drone was still sitting in the side bay, waiting to be deployed. And then, on the screen, something impossible happened. At 14 o'clock exactly, 5 minutes before they pushed the button, mouth B flared with light. On the video recording, the nose of the rover poked out of the sphere. Then the wheels. Then the whole body. In the recording, the drone tumbled out of the wormhole and rolled to a stop on the floor. It sat there for a moment, scanning the room, confusing the technicians in the video who had not yet sent it. It's there, Kale whispered, pointing at the screen. It arrived before we sent it. A closed loop, Aris said, breathing a sigh of relief. We have successfully navigated a closed time-like curve. We sent the drone at 14:05. It arrived at 14 o'clock. The loop is complete. But where is the drone now? Kyle asked, looking around the real hangar. It is parked over there, Ilara said, pointing to a dark corner behind a stack of crates. The technicians from 5 minutes ago moved it out of the way because they didn't know what it was. They thought it was a malfunction. Kale walked over to the corner. There, covered by a tarp, was Kronos 1. He lifted the tarp. The drone was warm. Its tires were slightly scuffed from the landing. It traveled through space, Kale said, touching the metal chassis. It didn't just rewind time. It physically traveled from the location of mouth A to the location of mouth B and arrived in the past. And it survived, Aris added. Look at the sensor logs. The gravitational forces inside the throat were negligible. No spaghettification. The negative energy held the walls apart perfectly. It was a smooth ride. Kale stood up, looking from the drone to the massive humming spheres. The implications were settling in. They hadn't just built a scientific curiosity. They had built a door that broke the rules of cause and effect. The delay was short, Aris said. Only 5 minutes. But the principle is proven. If we had kept Mouth B in the accelerator for 10 years, we could send a man back to warn us about a war before it started. We could cure diseases before the outbreak. Or we could cause a paradox that destroys the universe, Carl said soberly. What happens if I stop the drone from entering Mouth A? We already saw it come out. If I destroy it now, before it enters, what happens to the one that already arrived? The room went silent. This was the dark side of their invention. That, Aris said quietly, is why we need a human test subject. A drone does not have free will. It cannot choose to change the past. A human can. Elara stood up from her chair. She unzipped her technician's jumpsuit, revealing a flight suit underneath. I'm going, she said. Elara, no, Aris said, stepping forward. We need more tests. We don't have time for more tests, she replied, walking toward the wormhole. The director is right. We need to know if the timeline can be changed. And I am the only one who knows how to pilot the manual controls inside the throat if the exotic matter fluctuates. She stood before Mouth A. The distortion reflected her face, warping her features. I will go through, she said. I will emerge 5 minutes ago, and I will walk over to this console and stop myself from going. The grandfather paradox, Aris whispered. If you stop yourself, you never go. If you never go, you never stop yourself. Let's find out who wins, Elara said. Me or the universe? Me or the universe? Elara stepped forward. The surface of the sphere was cold, like a mist on a winter morning. She didn't hit a wall. She simply ceased to be in the hangar. The transition was not instantaneous. It was a physical sensation of movement, violent and strange. She was inside the wormhole throat. According to Dr. Aris's lectures, the throat was a manufactured tunnel through the quantum foam. It was space that had been folded, punched, and inflated. As she floated through, she saw what looked like a tunnel of distorted glass. The walls were not solid matter. They were the boundary of the universe. Beyond those walls was the space-time foam, the chaotic, bubbling labyrinth where geometry broke down and nothing made sense. She felt a strange, pulling sensation in her gut. This was the gravity of the wormhole trying to crush her, trying to squeeze the tunnel shut. But fighting against it was the exotic matter. The negative energy they had pumped in with the lasers and the Casimir effect was doing its job. It acted like a brace, pushing the walls outward. She felt lighter than air, suspended in a field of anti-gravity that kept her safe from the crushing pressure of the singularity. The journey felt like falling down a well, but sideways. Streaks of light passed her photons trapped in the curvature of the throat. Time had no meaning here. It felt like hours, but she knew it was less than a microsecond in the outside world. Then the tunnel widened, the pressure released, remaining. Ilara was spat out. She hit the concrete floor hard, rolling to absorb the impact. Her breath was knocked out of her lungs, and her head spun with a vertigo that made the room tilt wildly. She lay there for a moment, gasping, waiting for the nausea to pass. The air smelled of ozone and hot metal, the smell of the differentiator workshop. She pushed herself up on her hands and knees. She was back in the hangar. But something was wrong. She looked to her left. There was mouth A, the sphere she had just entered. But hovering next to it was mouth B, the sphere she had just exited. And standing in front of the control console, just 20 meters away, was a woman. The woman was wearing a flight suit, with a technician's jumpsuit half unzipped over it. She was arguing with two men. Ilara froze. She was looking at herself. She was looking at the back of her own head. Next to her past self stood Director Kale and Dr. Felicia. Harris. They were staring at the main monitor, watching the security footage of the drone appearing. "It's there," the past Kale whispered, pointing at the screen. "It arrived before we sent it." Ilara's heart hammered against her ribs. She had arrived exactly when the math said she would. She was 5 minutes in the past. She was witnessing the conversation she had just participated in. The realization hit her. She had to stop the loop. She had come back to test the paradox. If she walked over there and stopped her past self from entering the wormhole, the timeline would break. Physics would shatter. She tried to stand, but her legs were like jelly. The transit through the throat had taken a toll on her inner ear. She stumbled, knocking into a stack of metal crates. Clang. The sound echoed through the silent hangar. At the console, the three figures turned around. "What was that?" Past Kale asked, looking toward the shadows where Ilara was hiding. "Probably just the cooling system, settling," Past Harris said, dismissing it. "Focus, Director. We have a decision to make." Ilara pressed herself against the cold metal of the crates. They hadn't seen her. The lighting in the back of the hangar was dim. She took a deep breath, forcing her legs to steady. She had to move. She watched as her past self stood up from the chair. She heard herself say the words she had just spoken. "I'm going." "Ilara." "No," Past Aris said, stepping forward. "We need more tests." "We don't have time for more tests," Past Ilara replied, walking toward the wormhole. Now, the future Ilara thought. "I have to go now." She lunged from behind the crates. "Stop!" she screamed. Her voice came out as a raspy croak, weak and breathless from the journey. The roar of the magnetic accelerators masked the sound. No one turned. She ran. She sprinted across the concrete floor, her boots slamming against the ground. She was 10 meters away, 5 meters. Past Ilara was standing in front of Mouth A. She was looking into the distortion. "I will go through," Past Ilara said to the men. "I will emerge 5 minutes ago. And I will walk over to this console and stop myself from going. Future Alara was only a few feet away now. She reached out her hand. She could see the texture of her own hair, the stitching on the flight suit. She just needed to grab her arm and pull her back. "Don't do it," Future Alara yelled, finally finding her voice. Past Alara hesitated. She turned her head slightly, as if she heard a ghost, but gravity was already taking hold. Past, Alara leaned forward, committed to the step. Future Alara's fingers brushed the fabric of the jumpsuit, but she was a fraction of a second too slow. Past Alara stepped into the shimmering sphere of Mouth A. There was a flash of light as the mass entered the wormhole. The displacement of air knocked Future Alara backward. She fell to the floor, staring at the spot where she had just vanished. The loop was closed. She had failed to create a paradox. Or perhaps her failure was part of the history all along. Director Kale and Dr. Aris were staring at Mouth A, horrified. They hadn't seen Future Alara running up behind them because they were so focused on the woman entering the machine. Future Alara sat on the floor, panting. She looked up at the two men. Aris turned slowly. He looked at the wormhole. Then he looked down at the woman sitting on the floor. His eyes went wide. He looked back at the wormhole, then back at her. "Alara," he whispered. "I'm here," she said, her voice trembling. "I made it back." Kale spun around. His jaw dropped. "But you just left. I watched you leave." "I left 5 minutes in the future," Alara said, standing up shakily. "And I arrived here 5 minutes in the past. I tried to stop myself. I tried to grab her." "You couldn't," Aris said, a look of profound realization washing over his face. He pulled a chair over for her. "The Novikov self-consistency principle. You cannot change the past because you were already part of it. If you had stopped yourself, you wouldn't be here to stop yourself. The universe protects the timeline." "So I am stuck in a loop?" Alara asked. "No," Aris said. "The loop is done. A neighborhood, the you that just left, is currently traveling through the wormhole. She will arrive 5 minutes in the past, which is 5 minutes ago for us. She will try to stop herself, fail, and become you. You are the result. You are the final version." Quote, Kale rubbed his temples. "This is too much for a simple engineer. But the machine works. We have time travel. We do," Alara said, looking at the differentiator track that circled the room. "But 5 minutes is nothing. If we want to be useful, if we want to actually change things or learn from history, we need a bigger gap." "We can do that," Aris said, his scientific curiosity overriding his shock. "We put Mouth B back in the accelerator. We spin it faster. Longer. We can build a gap of years. Then we do it," Alara said, "because I don't want to just visit 5 minutes ago. I want to see something real." 10 years passed. Inside the Kronos facility, the passage of time was marked not by seasons, but by the relentless, never-ending roar of the differentiator. For a decade, Mouth B had been circling the magnetic track at 99.99% of the speed of light. It had become a blur, a streak of blue lightning that no human eye could focus on. Elara stood at the main console, her face reflected in the glass. She was older now. There were streaks of grey in her hair, and fine lines around her eyes that hadn't been there when they first tested the 5-minute loop. Director Cale had retired 2 years ago, unable to handle the stress of the long wait. Dr. Aris was still there, though he now walked with a cane, his eyes still burning with the same scientific fervor. "Today is the day," Aris said, his voice raspy. "The decade count is complete. We have kept the accelerator running at maximum capacity," Elara confirmed, checking the power grids. "According to the relativity counters, while 10 years have passed for us standing here in the lab, only a few seconds have passed for Mouth B." "The twins paradox," Aris nodded. "Bring it home, Elara." Elara initiated the deceleration sequence. It was a slow, delicate process. They couldn't just slam on the brakes. The inertial forces would tear the wormhole apart. Slowly, the magnetic fields reduced their pull. The high-pitched whine that had filled the building for 10 years began to drop in pitch, deepening into a rumble, and finally, silence. The heavy blast doors opened. The magnetic carrier glided into the central chamber, carrying Mouth B. It locked into place right next to Mouth A, which had sat motionless on its concrete pedestal for the entire decade. "It looks the same," the new director, a young man named Thorne, said. He was looking at the 2 shimmering spheres. "Appearances are deceiving," Aris said, limping closer. "Look at the clocks." They had placed a digital atomic clock next to Mouth A 10 years ago. It read the current date, December 5th, 2035. Next to it, they placed a camera feed, looking through Mouth A to the other side. Through the tunnel, they could see the interior of Mouth B. "Look through the wormhole," Elara instructed Thorne. "What time do you see on the clock inside?" Thorne squinted into the swirling surface of Mouth A. Through the distortion, he saw the lab. But the atomic clock, visible on the other side, didn't say 2035. "It says 2025, Thorne whispered. "It's 10 years slow." "Exactly," Aris said. "Mouth B has only aged a few seconds, while we aged 10 years. It is still living in 2025. We have established a permanent 10-year time difference between the 2 pandemics. So the bridge is built," Elara said. She felt a mix of triumph and melancholy. She had spent 10 years of her life building a shortcut back to the start. "We must be clear about the rules," Aris said, addressing the team of engineers who had gathered. "This is not a magic wand. We cannot go back to see the dinosaurs. We cannot go back to kill Hitler. The furthest back we can go is to the moment we created the time difference. Presses." He pointed to Mouth B. "That mouth is anchored in 2025. It will always be 10 years behind us. If we wait another 10 years, to 2045, Mouth B will be in 2035. We can never jump back to a time before the machine was built." "It is still a miracle," Thorne said. "We can send information back. Cures for diseases. Warnings about natural disasters. Payers, you," We can send more than information, Elara said. We can send people, pairs. It differs from the stories, Aris murmured, leaning on his cane. In H.G. Wells's The Time Machine, the traveler sits in a chair and watches the universe rewind. He fast-forwards or rewinds the movie of reality, but he stays in one place. And that is the problem with Wells, Elara added, reciting the lesson she had learned well. If you rewind time but stay in the same spot, you die. The Earth moves around the sun. The sun moves around the galaxy. If you go back 10 years without moving in space, you would wake up floating in the vacuum of deep space, millions of miles from where Earth used to be. Our machine solves that, Ara said, because it is a wormhole. It is a tunnel through space. When you step into Mouth A, you are not rewinding your own body's time. You are walking along a bridge to a place, Mouth B, that happens to be in the past. You travel through space to get to the time. It is a closed loop, Elara said. By executing a closed loop in space, you perform a closed loop in time. And it is two-way. She walked up to the shimmering portals. If I jump from A to B, she said, pointing left to right, I go 10 years into the past. I end up in 2025. And if you jump from B to A, Thorne asked. Then you go 10 years into the future, Aris said. From 2025 to 2035. It is a highway, past and future, connected by a 10-meter throat. Elara looked at the reflection of her graying hair in the wormhole's surface. 10 years ago, she had jumped back 5 minutes. Now she had the chance to jump back a decade. She could see her younger self. She could warn Kael about his health. She could fix mistakes made in the last 10 years. The probe is ready, Elara said, shaking off the temptation. We start with an unmanned test, just like before. Agreed, Aris said. But this time, the probe will not just sit in the lab. We are sending it to a specific location. We are going to test the spatial displacement. Coordinates locked, Elara said, returning to her station. We are sending the probe through Mouth A. It will emerge from Mouth B in 2025. We will program it to drive out of the lab and hide in the desert until today, 2035. If it works, Aris said, we should be able to go outside right now and dig it up. It should be rusty. Initiating launch, Elara said. The heavy blast doors opened again, and a new, larger rover, armored against the elements, rolled toward the time machine. This was the final exam for the differentiator. The armored rover, nicknamed the Timekeeper, rumbled across the hangar floor. It was built like a tank, designed to withstand a decade of burial in the harsh conditions of the Nevada desert surrounding the facility. Injection in 10 seconds, Elara announced. Her hands were steady, but her heart raced. This was the culmination of her life's work. Remember the target logic, Dr. Aris reminded the team. The rover enters Mouth A today in 2035. It exits Mouth B in 2025. It will immediately exit the facility, drive 5 miles north into the exclusion zone, and bury itself. Then it waits. It waits for us, Thorn said. It waits for 10 years. Go, Elara commanded. Now vision, now vision, now. We have. The timekeeper accelerated. It hit the shimmering surface of Mouth A and vanished. There was no flash, no sound, just a sudden absence where a 2-ton vehicle had been. Telemetry check? Elara asked. Signal lost, the comms officer reported. As expected, it has entered the past. We cannot communicate with it because our receivers are not tuned to 2025 frequencies. But we don't need radio, Aris said, smiling. We have shovels. Elara stood up. Let's go. The team, led by Elara, Aris, and Director Thorn, exited the hangar. They climbed into a transport truck and drove out of the facility gates. The sun was beating down on the scrubland. They drove north, following the GPS coordinates that had been programmed into the timekeeper just moments ago. 5 miles out, in the middle of a rocky depression, Elara signaled the driver to stop. Here, she said, checking her tablet. This is the spot. There was nothing there but sand, rocks, and sagebrush. The wind whistled through the emptiness. It feels foolish, Thorn admitted, looking at the empty ground. We just sent it. How can it be here already? It has been here for 10 years, Aris said, leaning on his cane. If the machine works, that rover has been sleeping under our feet while we built the machine to send it. Elara grabbed a shovel from the back of the truck. Dig. The team started digging. The ground was hard, packed tight by years of rain and sun. For 20 minutes there was only the sound of metal scraping against dirt. Doubt began to creep into Elara's mind. Had the rover crashed? Had it been intercepted by security in 2025? Clang. The sound was dull and heavy. Elara froze. I hit something, she said. They dug faster, clearing away the red dust. A shape began to emerge. It was metal, dull and scoured by sand, but unmistakably manufactured. They cleared the roof, then the windshield. It was the timekeeper. Look at it, Thorn whispered. It's old. The rover was covered in a patina of age. The paint was faded. The tires were cracked from dry rot. This was not the shiny vehicle that had driven into the wormhole 30 minutes ago. This was a relic. Elara wiped the dust from the side panel. The mission patch was still visible, bleached by the sun. Battery check, she ordered, connecting a diagnostic cable from her tablet to the rover's external port. The screen flickered to life. The rover's internal clock read the date, December 5th, 2035. But the mission log showed a continuous sleep cycle of 87,600 hours. It arrived, Elara said, her voice choking with emotion. It arrived on December 5th, 2025. It drove here. It buried itself, and it waited for us to catch up. Aris sat down on a rock, looking at the rusted machine. Tears streamed down his wrinkled face. We have broken the arrow of time. We have proven that the future can influence the past. But we didn't change the past. Elara pointed out, looking at the undisturbed desert around them. The rover was always here. We just didn't know it. We didn't dig here yesterday because we hadn't sent it yet. The loop is self-consistent. So we can't change history? Thorne asked, looking disappointed. We can't stop wars? We can participate in history, Harris corrected. We can be the reason things happened the way they did. Maybe we already are. Maybe a cure for a plague in 26 appeared mysteriously because we sent it back from 2036. We just haven't done it yet. Elara looked back toward the facility in the distance. The hum of the differentiator was silent now, but the bridge was open. We have a choice now, she said. We have a 10-year bridge. We can widen it. We can keep spinning the mouth. We can make it 20 years, 50 years. We can build a road for our grandchildren to visit us. Or, Aris said softly, we can close it. We can collapse the throat. We have proven it works. Maybe that is enough. The temptation to meddle, it is dangerous. Elara looked at the rusted rover. She thought about the 10 years she had spent in that lab, watching the lights spin. She thought about the grey in her hair. We don't close it, she said firmly. We maintain it. But we regulate it. We have created a new dimension of travel. We are not just explorers of space anymore. We are explorers of time. She patted the dusty hood of the timekeeper. Welcome back, she whispered to the machine. You took the long way around. They loaded the relic onto the truck. As they drove back to the facility, the sun began to set, casting long shadows across the desert. To the west, the first stars were appearing. Somewhere out there, light from the past was just reaching Earth. And now, in a concrete bunker below the sand, humanity had built a tunnel to meet it. The return to the Kronos facility was a solemn procession. The armored truck carrying the rusted, sand-scoured hulk of the timekeeper rolled through the heavy security gates, followed by the team. When they unloaded the rover in the center of the main hangar, the juxtaposition was jarring. On the left stood the gleaming high-tech control deck and the shimmering, ageless sphere of Mouth A. In the center sat the rover, a relic that looked like it had been abandoned in a scrapyard for a decade. Technicians swarmed the vehicle, treating it like a holy artifact. They ran carbon dating scans on the tires, chemical analysis on the chassis rust, and deep diagnostics on the memory cores. The data is incontrovertible, Doctor, Aris said an hour later, standing by the main display. The room was packed with staff, all silent, hanging on his every word. The atomic decay in the rover's hull materials matches exactly with a 10-year exposure profile. The digital logs show 10 years of standby mode. This machine has lived through a decade that we haven't experienced yet. Elara stood by the wormhole, staring into the swirling distortion of Mouth A. It changes everything, she said softly. It proves that the past is solid. It's not a memory. It's a place we can drive to. Director Thorne paced the floor, looking anxious. But this breaks every rule of causality we know. If I send a message back to 2025 telling myself to buy a certain stock, I become rich. But if I'm rich, maybe I never take this job. If I don't take the job, I never send the message. You are thinking like H.G. Wells, Aris said, tapping his cane on the floor. You are thinking of time travel as a rewrite button. You think the universe is a videotape that you can rewind and record over, but that is not what we have built. Aris walked over to the whiteboard, wiping away old equations to draw a simple circle. In Wells's story, the time machine sits in a Victorian parlour. The traveller pulls a lever, and he stays in the parlour while time accelerates backwards around him. He sees the sun flashed like a strobe light. He sees walls decay and rebuild. He is unmoving in space, but moving in time. And that is impossible, Alara added, turning to face the group. As we discussed, the Earth moves. If Wells's traveller sat still for 10 years, the Earth would leave him behind. He would materialize in the vacuum of space. Our machine solves that because it is a tunnel. It is a spatial journey, and it is a spatial journey. She gestured to the two mouths. When the timekeeper entered mouth A, it didn't rewind. It traveled. It moved along a 10-meter bridge of folded space. It exited mouth B. It was still moving forward in its own personal time. But because mouth B is anchored in 2025, the destination happened to be in the past. It's like flying from London to New York, Aris explained. You land before you took off because of the time zones. But you didn't travel back in time by magic. You traveled across space to a place where the time was different. We have just created a time zone difference of 10 years. So the paradoxes? Thorne asked. The universe is a block, Aris said. Past, present, and future exist simultaneously. The rover was always buried in the desert. We just didn't look for it until today. The loop is closed. Consistency is maintained. Dejub, Mr. Unman said. Therefore, they're both there. Underneath, she was wearing a telemetry suit, wired with sensors. The rover survived, she said. The sensors showed G-forces were minimal, radiation levels were nominal. The exotic matter held the throat stable. The room went quiet. They knew what was coming. I'm going, Alara stated. I want to see 2025. Alara, Thorne warned. Sending a robot is one thing. Sending the lead engineer is another. If you get stuck there, you have to wait 10 years to get back to this moment. I know, she said. If I step through mouth A now, I emerge in 2025. To get back here to 2035. I can't just turn around and jump back through mouth B. That would send me another 10 years into the past, to 2015. To get back to now, I have to live through the 10 years. I have to take the long way home. A one-way trip to the past, Aris mused. Or rather, a shortcut to the beginning of a long journey. I'm not staying for 10 years, Alara corrected. The loop is two-way. Remember the differentiator? We separated the mouths in time, but we can bring them together in space. Mouth A is here in 2035. Mouth B is here in 2025. But physically, They are right next to each other in this room. Ah, she walked up to the portals. If I jump from A to B, she pointed left to right, I go to 2025. I can look around, talk to my younger self, give her a high five. Then, to come home, I just have to walk through mouth B backwards? No, that pushes me further back. I ask you. She paused, frowning. The geometry of space-time loops was a headache even for its creators. Wait, Aris said, his eyes lighting up. Think about the neutron star example. Viewed through the wormhole, the clocks are synchronized. Viewed through normal space, they are different. If you step from A to B, you are in 2025. You are standing in this room 10 years ago. To get back to 2035 instantly, you would need to step from B to A. But in 2025, mouth A hasn't experienced the time shift yet. And he rubbed his temples. Actually, Director Thorne is right. The machine connects 2035 to 2025. It is a bridge. If you cross the bridge to 2025 and then turn around and walk back across the bridge, you return to 2035. It's just a door. You can walk in and out. Alara breathed a sigh of relief. So I can visit. I can go to 2025 for lunch and be back in 2035 for dinner. Theoretically, Aris said, as long as the throat stays open. If the throat collapses while you are on the other side, then you are stuck in the past, and you will have to wait 10 years to catch up to us. I'll take the risk, Elara said. She pulled on her helmet. The preparations were swift. The medical team checked her vitals. The engineering team boosted the power to the inflator lasers to ensure the negative energy density was at maximum. They couldn't afford a flicker in the exotic matter while a human was inside. Elara stood on the platform. The sphere of Mouth A was mesmerizing. It wasn't just a mirror, it was a window. If she looked closely, near the edges, she could see the lab on the other side. It looked slightly different. The equipment was newer. The paint on the walls was fresh. She was looking at the lab of 2025. Comms check, she said. Loud and clear, Thorne replied. Remember, you are embarking on a journey into space that ends in the past. Don't think about the time. Just walk. Elara stepped up to the edge. She could feel the faint tidal forces, a gentle tugging at her atoms. The Casimir energy hummed, a shield against the crushing gravity of the singularity. She took a breath of the recycled air in her helmet. Initiating transit, she said. She stepped forward. The sensation was not like falling. It was like sliding sideways through a thick curtain of water. The light bent around her. For a split second, she was nowhere suspended in the throat, surrounded by the violent, swirling foam of the quantum vacuum, protected only by the bubble of negative energy they had manufactured. Then, the pressure released. She stumbled forward, her boots hitting concrete. She steadied herself and looked up. The hangar was the same, but different. The lighting was brighter. The smell of ozone was sharper. She turned around. Behind her hovered the two wormhole mouths. But the people in the room were not the team she had just left. Standing at the console, looking young and tired, was Dr. Aris. Next to him was a younger version of herself, holding a tablet, looking frustrated with a simulation. They didn't see her yet. She had emerged silently from the portal. Elara opened her visor. She was in 2025. She had traveled 10 years back, not by rewinding the universe, but by taking a shortcut through the geometry of space. "Dr. Aris?" she called out. The younger Aris turned. He dropped his coffee mug. It shattered on the floor, the sound echoing through the decade. The sound of the shattering ceramic mug seemed to hang in the air for a long time. In the silence of the 2025 laboratory, 3 people stood frozen. Young Dr. Aris stared at the woman in the strange suit, who had just materialized from the swirling air. Beside him, young Elara, 10 years younger, her face smooth and unlined, stepped back, her hand instinctively reaching for a wrench on the console. "Who are you?" young Elara demanded, her voice sharp with fear. "How did you get in here?" "Security. Cancel security," the older Elara said calmly, removing her helmet. She shook out her hair, revealing the streaks of grey that had appeared over the last decade. She looked directly into her own younger eyes. "You know who I am. Look at me." Young Elara froze. She looked at the woman's face, the same nose, the same eyes, the same scar on the chin from a childhood bicycle accident. She looked at the flight suit, patched and worn, bearing the insignia of the Kronos project, but with a rank she hadn't earned yet. "Me?" young Elara whispered. "But you're old." "I'm 10 years older," Elara replied with a tired smile. "I just walked through the bridge. I came from 2035. Young Dr. Aris stumbled forward, ignoring the coffee pooling around his shoes. "It worked," he breathed, his eyes wide with wonder. "We didn't just create a resonance. We created a stable throat. You physically traveled here." "I traveled through space," Elara corrected him, quoting the lesson Aris himself would teach her many times over the coming years. "I took a 10-meter walk that ended 10 years in the past. The wormhole is stable. The exotic matter held. The negative energy from the inflator is doing its job. 256. "Why are you here?" young Elara asked, stepping closer, her fear replaced by a burning curiosity. "Did something go wrong? Did you come back to warn us? Do we need to shut it down?" "No," Elara said firmly. "That is why I came. To tell you not to shut it down." She looked around the lab of 2025. It looked so clean, so new. They had no idea of the long, grinding years ahead. The noise of the differentiator, the endless maintenance cycles, the political pressure to close the project. "In a few months," Elara told them, "the funding committee will try to cut the power. They will say the machine is a waste of money because nothing is happening. They will say that keeping Mouth B spinning in the accelerator is pointless. Yosef," she pointed to the shimmering sphere of Mouth B, which was currently humming in the magnetic track behind the wall, beginning its long journey of time dilation. "You have to keep it running," Elara said intensely. "You have to fight for it. It takes 10 years to build the bridge. If you turn it off, the tunnel collapses. The connection is lost forever. You have to wait. You have to believe. We will, young Ares said, straightening his back. Seeing you. This is all the proof we need. We are looking at the future. And one more thing, Elara added. About an hour ago, a rover called the Timekeeper arrived in the desert, 5 miles north. It buried itself in the sand. Leave it there. Do not dig it up. We need to find it in 2035 to prove the timeline is consistent. Young Elara nodded slowly, processing the logic. A closed loop. It's already there. Elara looked at her younger self one last time. She wanted to tell her so much more. She wanted to tell her to spend more time with her parents, to take better care of her health, to not worry so much about the data, but she knew she couldn't. The timeline was fragile, or perhaps it was rigid. Either way, she had played her part. I have to go back, Elara said. My dinner is getting cold in 2035. How? Young Ares asked. If you go back through the wormhole, won't you go further into the past? No, Elara said. Think of the geometry. I am currently standing in 2025. The wormhole mouth next to us, mouth B, is the younger mouth. It connects to mouth A, which is the older mouth in 2035. If I step into the young mouth, I come out of the old mouth. I go forward. She put her helmet back on and sealed the visor. The telemetry lights on her suit blinked green. Good luck, she said to them. The next 10 years are going to be hard. But they are worth it. She stepped onto the platform. The swirling vortex of the wormhole waited for her. To the people in 2025, it was a doorway to the future. To her, it was just the front door to her own time. She stepped through. Again, the sensation of sliding sideways through the universe, the rushing of quantum foam, the bending of light, the feeling of being everywhere and nowhere at once. And then, a sudden release of pressure. Elara stumbled out onto the metal grating. Welcome back, Director Thorne's voice boomed. She looked up. Belated. Belated. She was back in the dim industrial hangar of 2035. The rusted rover was still sitting on the truck. The air smelled of old grease and ozone. It had been less than a minute since she left. Dr. Aris, the old doctor and doctor. Aris hobbled over, a look of immense relief on his face. You made it. You closed the circle. I saw you, Elara said, grinning as she removed her helmet. I saw you 10 years ago. You dropped your coffee. Aris laughed, a dry, wheezing sound. I remember that. I remember a woman appearing in a strange suit and telling us to keep the power on. I thought I had hallucinated it. I spent 10 years wondering if it was a dream. But it was you. It was always you. Elara looked at the two shimmering mouths of the wormhole. They were no longer just a science experiment. They were a permanent fixture of reality. A tunnel had been bored through the block of space-time, connecting two eras as surely as the Channel Tunnel connected England and France. "We did it," Elara said, wiping sweat from her forehead. "We didn't just build a machine, we built a place. A place where the past and future meet." "It is not like the stories," Aris said, looking at the swirling lights. "We didn't rewind the universe. We didn't change history. We simply joined the architecture of the cosmos." Elara looked at the thermometer, which showed the view from the other side, the clean, bright lab of 2025. She saw her younger self waving at the wormhole, a gesture across a decade. Elara waved back. "We are not time travelers," Elara said softly, watching the image of her past. "We are road builders. And the highway is finally open."